Alright, hey Pritzker people, we're back with another video. This is objective 147. Students will be able to write the equation of a line given characteristics of that line, or of the line itself. Go ahead and pause and get that down. I should say this is objective 147, but it applies to objectives 144, 145, 46, and frankly every objective in this unit. This will be a free-form video in the sense that it's not going to match your note packet perfectly. Everything we do in this video is applicable to what we've been working on in class, and all supporting our progress towards being able to write the equation of a line given pretty limited information. Now I want to give some background, okay? So we've been dealing a lot with this equation for a line, y equals mx plus b, which we know is slope-intercept form. Now, before I talk a little more about this, I want to make sure you're aware that this is just one way to represent the equation of a line. We're actually going to learn two other forms. That says ax plus by equals c. That's called standard form. And there's another one where you subtract your y values, and that's the same as multiplying the slope times the change in the x value. And this is called point slope form. Now, our focus for right now in this video is this. We'll get to these actually pretty soon. But the reason we like to start with this one, this is again slope-intercept form, is because it's probably the best introduction into how x and y variables relate to forming a line. It's very user-friendly, for lack of a better term. Like, it tells us really obviously what the y-intercept is, so where this line crosses the y-axis. Also very obviously tells us what exactly the slope is. That's why most algebra classes start with this, because once you understand this, we can start building into these more complicated equations for lines. But I just wanted to make that point. It's not like this is the end-all be-all. It's just one way to represent the equation of a line. So I should also say off the bat that I can't promise this video is perfectly short. We haven't had a few. We haven't had a video in 3 or 4 nights of homework, so that's kind of the trade-off I'm giving you. But this video, if you're having any trouble at all with trying to find the equation of a line, graphing it, looking at a graph of it, and then trying to write the equation, given a point, and given a lot of stuff, this is the video for you. Like, this is the one you really need to understand, as it's going to contribute most to your understanding of linear equations, which is the foundation of algebra. Before we hop into actual examples, I just want to remind you all, this equation for a line, all it's really doing is relating your x and y variables. Let's use an actual, more tangible example. Let's say we had a line that had a slope of 2 and a y-intercept of 4. We can do a quick sketch. I mean, it's going to cross the y-axis right here at 4, and would slope up 2 over 1. And that would be, that's what this line looks like. Now, all this is doing is, like I said, it's establishing a relationship between your x and your y value. It goes back to when we first started with input and output. Whatever you put in for your x, you're going to get out for your y. And the reason we never actually plug in like permanent values for x and y is because they could represent any ordered pair. That's all slope-intercept form and an equation for a line is showing you. It's telling you how your x values relate to your y values. It's just establishing that relationship, and knowing that, we can then figure out any ordered pair on this line. Even if it's not a perfect point, it could be a decimal value. It just tells us how our x and y values interact together. It lets us know like how our y is going to respond based on what we put in for x, and it gives us every single value on this line if we know the slope and the y-intercept. It lets us know that relationship. All right, let's hop into some examples. But before we even get started, before I say anything else, I'm going to ask you, and hopefully you already know, what are the two things we must know to write the equation of a line or to graph the equation of a line in slope-intercept form? Hopefully you said, and I have to write this down. 1, we have to know slope. And 2, we have to know the y-intercepts. Now, if you said intercepts, you're not wrong. If you knew the x-intercept, you could definitely still graph the equation for a line. What's really key is you have to know the slope and a point, because that's what the y-intercept is. It's an ordered pair. So as long as we know the slope and an ordered pair, we're good to go. We like to find the y-intercept because that then allows us to write the equation of the line. You'll see in a bit we can still write the equation of a line if we have the slope and a point on that line. But let's look at the first example. I'm always looking for what's the y-intercept and what's my slope. So right away I'm going to start with the y-intercept. Pretty obvious, that's 4. That's the ordered pair 0, 4. And now I'm trying to find slope. Whenever we're going after slope, we want to identify those latest points, the perfect or lattice points. It's really however you want to say it. Those perfect points that come at a perfect whole number ordered pair. So I see a value there and right there. And to find slope, I'm just going to do rise over run. You're more than welcome to actually write out the order pairs and use our y2 minus y1 formula. But if I'm right here, to go to that next one, I have to go up 2 in the positive direction and over 1. So my rise over run is equal to 2 over 1. So that's a slope of 2. So the equation for this line, start with y equals, I know the slope is 2. So I'm not going to write m, I'm going to plug in 2. The x stays the same. And then my y-intercept is 4, bam. That is the equation for this line, and we just saw that one. That's y equals 2x plus 4. Now let's check this one out. So right away it tells me that the slope is 2, and the y-intercept is negative 4. So before I even try to graph that, I know how to write the equation for this line. If I know the slope, I'm going to write it right here in the middle. If I know the slope, I'm going to plug it in, y equals 2x, and the y-intercept is negative 4. So I'm going to put minus 4. I've seen a lot of students do plus negative. If you're adding negatives, you're subtracting. So make it simpler and just put minus 4. And now I'm going to graph this so we know what it looks like. I know this has to be a point on the line because that's the y-intercept. And then to plot the slope, I go up 2 over 1. I went up 2 in the positive, over 1 in the positive. We'll get a few more points, up 2. And then I borrowed a ruler from Ms. Budson. Thank you, Ms. Budson. Let's see how I do. And that's what that line looks like. So that's stuff you all have done really well. Let's try some harder examples. Okay, we're here on the bottom of page 33. Again, whenever you're looking to draw the equation of a line on a graph, or actually write the equation of a line, you're looking for two important things. What is the slope, and what is the y-intercept? So looking at this first one, I know the slope, so I can go ahead and start to write this equation. I know it's going to be y is equal to 3 times that x value, but I'm missing the y-intercept. So let's use the information given to figure that out. I know that the point 1, 1 is on the line because the problem tells me that. Now, I'm trying to figure out what the next point is. Well, a slope of 3, if I set that equal to my rise over run, right here, if this is confusing. You're essentially trying to figure out what the run is, and you're asking yourself, what value could I divide 3 by that's not going to change it? That's just 1. So I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. And then I could just connect these and hope that I'm really accurate. If you're a little advanced, you could think, okay, I know that a negative divided by a negative is a positive. So if I still want to represent a positive slope, I can go down 1, 2, 3, and then go back 1. And that's still going to be a point on this line. It still represents a slope of 3. So now thanks to Ms. Budson for letting me borrow this ruler. Always include arrows at the end. It lets your reader know that you understand this line goes on forever. And that's what this line looks like. And now we know the y-intercept. It's right there at negative 2. So y-intercept, I'm going to erase that and try that again. So y-intercept equals negative 2, which is 0.0 negative 2. So in my equation, I'm putting y equals 3x minus 2. And that's the equation for this line. Same idea with number 2. I'm given a point on that line. That's negative 3 and then positive 6. And I'm given a slope of negative 1/3. Again, slope we can say is equal to rise over run. When I'm given a graph, that's the way I like to calculate slope. So my rise is negative 1. My run is a positive 3, so I'm going to go down 1 over 3. And you can see right there, there's the y-intercept. We could go ahead and write the equation for this line. So it's y equals negative 1/3 x plus 5. That relationship helps us figure out every other point on this line. just for fun, let's plot a few more points, and let's see what this line looks like. Through doing a lot of examples like this, Ms. Hyder and I hope that you're starting to understand, to get a sense of, a very steep graph has a much steeper, much larger slope, whereas this is not a very steep, it's not a very sloped graph, and that makes sense because the slope is just negative 1 over 3. So I feel like these are the problems that I've seen students have a lot of success on. Let's see how we do when given even less information and not given a graph to work out what the line is going to look like. Alright, we're on what I think is page 35, I'm pretty confident, on example 3, and this is where I've seen students start to struggle. So let's figure out how this looks. And I'll give you an example of the struggle. So what I've seen students do is try to go back to their old tricks. So they're like, okay, I know that point 1, 2, 3, 4 and negative 2 is on this line, and the slope is 5, so it's up 1, 2, 3, 4, 5, 1, and again, and then they try to graph this, and they start to realize, like, oh man, the y-intercept is somewhere all the way down here, and okay, I'll keep going, and so it's got to be right there, but what if your scale is not accurate? Like, what if you're not perfect? You're putting yourself in a spot where you're essentially having to guess at what the y-intercept is. There's no reason to guess. We can actually be 100% exact. I'm going to show you right now. So whenever you go after a problem, or when you're trying to write the equation of a line, again, you need slope and y-intercept. Well, they gave us slope, which is ever so kind. So we know that the equation is going to start y is equal to 5x. But we're missing our y-intercept. We don't know that b value. And if you're looking at this, you're like, well, we have 3 variables, but that's not entirely true because they gave us a point on this line. That point represents an xy pair, so knowing this point has to be on the line, we're going to substitute. So if I know the y value, or at least a y value, when y is negative 2, I know that the corresponding x value is 4, because that's the input that determines that output. I can then just solve this equation, which you all are really good at. 5 times 4 is 20, plus whatever this value is, and when I subtract 20 from both sides, ta-da! The y-intercept is negative 22. So you saw that graph how it was moving way down here. Now we know it was actually exactly going to cross the y-axis at y equals negative 22. So the equation for this line is y equals 5x minus 22. I forgot to box my answer. Please box your answers. Your work's very confusing sometimes. Box your answers. Okay. Example 4. Now this one tried to trick you, and it might have done just that. We're looking for slope and y-intercept. It actually gave us the y-intercept this time, but not the slope. So if I start to write my equation for this line, it's y equals, I gotta just put m, because I don't know the slope value, mx plus, but I don't have to put b because, well, I know that value. It told me that the y-intercept is 3. Recall that y-intercept is denoted with the variable b. Just for simplicity's sake, so we as a math community can always communicate about certain things. So now, same idea as example 3, let's plug in what we know. We know that when the x value is 3, it produces a y value of 2, so I'll plug in 2 for y. I'm going to leave m as a variable because I don't know it. And then plug in for x, and then I still have plus 3. Let's rewrite this a bit just to make it look more familiar. I'm going to put the coefficient in front of the m. And now I'm just trying to solve. I'm going to subtract 3 from both sides. So I have negative 1 is equal to 3m. And then divide both sides by 3. And oh man, can you believe it? We figured it out again. The slope is negative 1/3. So the equation for this line is y is equal to negative 1/3 x plus 3. Now we were told in this problem, this is still example 4. I'm just now showing you, I'm proving that this is totally true, that that is the equation for this line. We were told that the point 3, 2 was on the line and the y-intercept was 3. So now, given a graph, I'm going to prove it. That is actually the equation we were able to algebraically figure out. It's so cool. So now 3, 2 is on this line. I'm going to move it. I'm back, it shifted, so I don't have to draw over top of that. So 3, 2 is on this line, and I know the y-intercept is 3. And so now when I connect those, and you know, actually no, I'm just going to connect this. I want to show that if I do a really good job, which wish me luck. Oh, off to a rough start. That's why. Okay, that was far from a really good job. But we can actually see now, if I were to calculate the slope, so I'm right here going to this point, I go down 1, so that's a rise of -1 and over 1, 2, 3. So the run is 3, and that's a slope of -1/3, which, check it out, we already had that. So it's not random, it's the algebraic way to calculate what we already figured out. All right, just two examples left. I really hope you're still with me because it's crucial information. This is the crux of understanding linear equations and how to figure out what the equation of a line is. I'm going to do example 11 on page 36. For all this stuff, I didn't say it in class, but I hope you got the memo to not do this on this page. Please use a separate sheet of paper. You just don't have space to do it all there. Now it's saying write the equation of a line. It didn't say it in any form, so I'm going to write it in slope-intercept form because we're more familiar with that. So write the equation of a line that passes through the x-intercept with a slope of -3. That's kind of tough because it didn't give us a lot of information, but it gave me a point and a slope. So I can use that to write the entire equation for this line. I know the x-intercept is 4. That's going over 4, so that point is 4, 0 on the coordinate plane. So I'm going to work down here. I have point 4, 0 and a slope of -3. So again, starting with my y equals mx plus b, just the generic equation for a line, let's substitute what we know. We know that when x is 4, the y value is 0, and I know my slope has a value of 3, so now I just have to solve for the y-intercept. I'm going to work over here. -3 times 4 is -12. If I add 12 to both sides, I get 12 is equal to b, meaning that this line crosses the y-axis right at 12. So the equation for this line is y equals -3x plus 12. I hope by now these are getting easier. These are super easy. I can totally do this. And if we were to graph this, we'd see that this point, that's exactly the point on this line. It crosses the the x-axis right at 4. And again, if you're trying to prove you're right, plug in a point, and your point has to balance both sides because that's actually a point on the line. So if I put 4 in for x right there, 4 times 3 is -12. 4 times -3 is -12. -12 plus 12 is 0, and that's my y value there. So it's just further proof that your equation is correct. One more. Last example, example 2 on page 37. You might look at it and be like, whoa, that didn't give me the slope or the y-intercept. What in the world do I do? But you're not going to do that because we can figure this out. Again, we're looking for slope and the y-intercept. If we know that, we can grab any line. Before I even get into these, when I'm just giving 2 points, what I like to do is what I call just a quick sketch. I want to get an idea of, is this slope going to be positive or negative, and how steep is it going to be? It lets me know if I make an atrocious mistake in my algebra. So the point 1, 2, 1, 2 is about there, and then 2, -4, 1, 2, right here. So when I connect these, okay, I'm looking at, I should have a positive y-intercept, and this line is a negative slope, pretty obviously. When I connect the dots that I'm given, that line has a negative slope. So that's what I'm looking for in my process. If I don't have a negative slope, I probably made a mistake somewhere with my algebra. Okay. If I have to know slope and y-intercept, let's start with figuring out the slope, because we can do that. Given 2 points, we can easily find the slope. I'm going to use our slope is equal to y2 minus y1 over x2 minus x1. I'm going to choose to label this x1, y1, and x2 and y2. Let's go ahead and substitute. My y2 value is -4. I put all these in parentheses just to be safe. Then -1, all divided by 2, minus 1. Pardon me. I think I made a mistake. I did y2. Sorry about that. Should be negative 4 minus my y1 is 2. And then my x2 is 2. And now I'm good to go. So negative 4 minus 2 is negative 6. 2 minus 1 is 1. So my slope is negative 6. Okay. So we've got one piece. We know the slope. It's negative 6. So in this equation, we have y is equal to negative 6x plus, we don't know the y-intercept though. But we actually know 2 points on this line. So here's the cool thing. You have choice now. If you know both of these are on the line, you can plug in any ordered pair for your x and y value. So let's do just that. I'm going to choose this first point because why not? This first point, the input value is 1. So I have, I'm going to work right here. So I have 2 for my y coordinate is equal to negative 6 times 1 plus b. That simplifies that 2 is equal to negative 6 plus b, and then I add 6 to both sides. 8 is equal to b, which is code for that's where the y-intercept is. That's where this line crosses the y-axis, so let's put it all together. Y is equal to negative 6x plus 8. Check it out. You all did it. Like you wrote the equation of a line, a unique line, given super limited information. And that's what this objective is all about. Now, a quick just reality check. Let's make sure that makes sense here, and it does. Like, I don't know this is my rough sketch, but you can see that this could be a y-intercept of 8, and it's definitely a pretty steep negative slope, so it makes sense that the slope is negative 6, okay? If you have questions, please let me know. I have the utmost confidence you all can do this. Please finish everything that was assigned in class, and we'll see you next time.